Hey guys, Chase from Radar Robotics here. Today we'll be installing Android Studio and all the software required to make our first OpModes. We'll also be downloading Github to reap the rewards of version control alongside RoadRunner and MeepMeep for smooth autonomous pathing and visualization. There's plenty to cover, so there's timestamps in the description if you want to use them, but without further ado, let's get into it. Alright, so here we are on my desktop. What we're going to do first is go ahead and download Android Studio. So we're going to open up a browser. Go ahead and type Android Studio into the browser. You should see the first choice, obviously from the Android developers. So what we're going to do is just click this one here. As of right now, Android Studio Narwhal for me is the most recent. It doesn't necessarily matter which Android Studio you download. The steps should be relatively similar. So I'll just scroll down, accept the agreements, and then go ahead and download Android Studio here. Alright, now that Android Studio is downloaded, all we're going to do is go ahead and open it. So go ahead and open a File Explorer, go to your downloads, and then just double click on that application that downloaded. We're just going to go ahead and uninstall the old version. If you have a version previous, I do of course, go ahead and keep clicking next, and then let it install. Okay, and the installation is complete. Just go ahead and click next, and then just click finish. Okay, now that Android Studio is open, you should see something like this. It's just going to ask you if you want to make a new project, open, or clone a repository. What you should go ahead and click is clone repository. From here, we're going to go back to our browser. What we're going to do is we are going to look up RoadRunner Quick Start. So at this point right now, I am going to go ahead and download the RoadRunner GitHub repository. What this has is it has the First Tech Challenge repository with all of the classes and objects that we need, the servos, the DC motors, autonomous and manual op modes, all of that. What this has as well is RoadRunner. So RoadRunner is a autonomous pathing tool that we will be using, or at least I will be using in the future, to create more smooth autonomous paths that are much more reliable and easier to make and work through. So in this tutorial, I will be downloading the RoadRunner repository, but of course you can go ahead and download the regular FTC repository and follow the steps in their README for that. But anyway, what we're going to do here is click code. Go ahead and copy this link right here, and then go ahead and go back to your Android Studio, paste in that URL here. You can choose your directory, of course. I have a directory in my users. It's just called Studio Projects, and that's where I store all of my Android Studio repositories. So go ahead and click on that, and then just go ahead and click clone here. Now all that's going to do is take all of this repository here, all of these files and information, and just create a whole nother copy of it that we can access and change any files, create any files, and make any changes that we want. Okay, now that we have successfully cloned the project should open, if not open the project. What we have right now is the Gradle is syncing. From what I can tell, the Gradle is an application that allows version control, packaging, compilation, all of those things to occur kind of on these backends and through these files, so that we don't have to do a lot of the work with copying and pasting all of these files over. It makes things a lot easier in terms of getting other packages from the FTC SDK, and also with updating these files whenever RoadRunner makes any updates and changes to reflect any new seasons that come through. Alright, now that we have RoadRunner and the FTC SDK installed, we're going to go ahead and install MeepMeep. Go ahead down to your browser again. We're going to search up MeepMeep FTC. You should see Acme Robotics /MeepMeep. Go ahead and open that one. And then all we're going to do is walk through these steps. Go ahead down to the 6th step and copy this repository and dependencies Gradle snippet real quick. we're going to go ahead and go back to Android Studio. And now we're going to click on the FTC Robot Controller module, right click on it, go to New, then click on Module. What you should see is there's a Java or Kotlin library in the sidebar. Go ahead and click on that. We're going to rename this library name to MeepMeep Testing. We also need to change the class name to be the same thing. And then all you have to do is go ahead and click Finish. You can change the library name and class name to be anything you want, but just make sure they're the same. Go ahead and click Finish. If it asks you to add these files to Git, go ahead and click Add. If not, don't worry, we will figure that out. Now that we have our MeepMeep testing file made, go ahead and go down to this Gradle snippets and find the one that says module MeepMeep testing, this build.gradle here. We're going to click into this, go ahead and paste the snippet that we copied earlier. And then all we're going to do now is click Sync Now on this Gradle. If this doesn't show up, then you can go ahead and click this elephant in the top right. Okay, now that our project is synced, we're going to go back up to this MeepMeep testing module. Go ahead and click on Main, then go down to this MeepMeep testing file. What we're going to do is we are going to replace all of the code in here with the sample code that the README shows. So we're going to go ahead and copy and paste this into our Android Studio file. Now that our file is set up, we're going to go ahead and add a configuration to the Android Studio. You should see in the top that there is this team code section. This team code is going to be used to build your code onto your robot, but right now we are going to create another configuration that we can use for MeepMeep. Go ahead and click on plus in the top left, then click on Application. From there, we're going to rename this configuration to anything you want. I'm going to name it as MeepMeep. From here, we're going to go on to this -cp and click on the meepmeeptesting.main file, not the MeepMeep testing, but the meepmeeptesting.main. From there, the Java SDK should automatically populate. What we're going to do is go to this main class, and on the far right, there's a page button. If you click on that, it should automatically show you your MeepMeep testing file. Once you've done that, go ahead and click Apply, and then click OK. You should see in the top that it's changed your configuration to your new MeepMeep configuration. If you ever want to build code back onto your robot, you can just click on this MeepMeep dropdown, and then go back to team code, and vice versa. From here, now that we have a file set up, all that you have to do to test and run it is click the play button right here. But you should now see that we have this MeepMeep application showing, where it shows the path of the robot. It shows a timer that we can scrub through. You can also press space to pause it. You also have coordinates in the bottom left that show your precise position on the mouse. So if you want to say where the middle section of this is, it's at 57.6, 12.2. And yeah, that's about it for MeepMeep. Now that we have all of that set up, we can go ahead and look a little more into our files. What we have here is this FTC Robot Controller folder. This is most of the stuff behind the FTC SDK. There's not much that you really have to do here. There's a good few examples of code. So if you have any new, robot hardware, or for sensors, or for April tags, there's a lot of concepts in here that you can look at. But that's about it for this folder. What we're really worried about is this team code folder. Specifically in this Java section, there is this package, this team code package, and it has a lot of stuff pre-populated by RoadRunner. These are things that we will use when we set up RoadRunner in another video, but that's for a different time. What we're really focused on is this is the spot where you make all of your OpModes that you will use on the robot. In order to make this clean, I like to make a package. So you can go ahead and click on this org.firstinspires package, go ahead to New, and then go ahead and click on Package. From there, you can name this anything you want. I'm just going to name this tutorial just because this is a tutorial. You can name it your team name, you can name it OpMode, autonomous, manual, whatever you want. From there, if we wanted to make an OpMode in this, all you would go ahead and do is right click on that package, go to New, and then click on Java class. And then you can name this anything you want. I'll name mine sample OpMode. And then yeah, from there, all it is just your general setup that you know from the OnBotJava. Nothing different here. What we should be worried about is setting this up for GitHub, so we're going to go ahead and do that now. If you don't already have a GitHub account set up, you should go ahead and do that before making these steps, because obviously if we want to set this up for GitHub, you need to have an account to make the repository for. In order for Android Studio to figure out where it wants to send your repository, you need to give it your account. So what we're going to go ahead and do is in the top right, you should see this settings. We're going to go ahead and click the actual settings, and then go ahead and search GitHub. What you should see is the first thing that shows up, this version control / GitHub. Go ahead and click that plus in the top left, and then log in via GitHub. This will then prompt you to log in or authorize your GitHub if you've already signed in. So for example, I'm signed into my account right now, so it automatically said, okay, are you allowing us to access this GitHub account? So here's my GitHub account. Go ahead and click apply in the bottom right, and then okay. From there, all we're going to do is click on the menu, go to Git, GitHub, and then share project on GitHub. It says that the remote is already on GitHub. This is simply talking about the repository that we downloaded from, RoadRunner Quick Start. So go ahead and click share anyway. You can change the repository name to whatever you want. I would probably say use your team name or the year, anything like that. You don't really have to worry about any of these other settings. Just go ahead and click share. Now this is going to push this to the GitHub website. And then once it's completely done, you should be able to go back to your browser. If you're logged into your GitHub, you should just be able to refresh. And there we are. You have your tutorial. Now there's one more thing that we need to do in order to set up the GitHub repository correctly. So let's go back up to the taskbar, go ahead to Git, and then go ahead and click on Manage Remotes. So we have two remotes here, and this might not make much sense right now, but we have an origin. The origin remote is simply where we are going to take all of our files and upload them to. This is currently set to the repository that we cloned, the Acme Robotics repository, but that is not our actual origin. So what we need to do is change the origin remote to this GitHub link, or whatever your account is / your repository name. So for me, Chase-Crawford /tutorial. So what we're going to do is we're going to rename this origin repository to upstream. We're still going to have this remote because this will allow us to fetch any updates that Acme Robotics makes to the RoadRunner SDK, but we will move our changes to our private file. So we'll call this upstream, and then we will change the Chase-Crawford /tutorial, or whatever your repository is named, to origin. Now this should properly upload all of our changes to this origin repository and fetch anything that we need from this upstream remote. Now you should be able to go to a browser and open your GitHub account. And if you go to your repository section, what you should see if you look in this is that we don't have a MeepMeep file. And if you go into our team code, go to main, go to team code, you should see that we don't even have the package that we made. This is not a problem, because what has happened is we haven't commit the changes that we have made to this repository since, so we have to do that now. All this is that you have all of these changes on your client side, but what we need to do is commit these files to the new GitHub repository. Right now, we're just going to go ahead and commit to master or to main, but in the future, what I would highly suggest is making branches. All you have to do is click on this new branch and then just make a new branch name. So for example, I'll just make it testing. We're going to go ahead and create this branch. From here, you can go ahead and do all of these files. Go ahead if you want to make a message. So creating MeepMeep and our first OpMode file. This is really good for you to check what commits have changed in the code at a glance. So what we're going to do is go ahead and click commit and push. If you wanted to take multiple commits in a branch before pushing it to the GitHub repository, then you can just click commit. But we're just going to go ahead and click commit and push. Wait for that to send. So of course we ran into a problem here. GitHub is providing us with a warning that we must check before we go ahead and push. So let's go ahead and look at this. If we go ahead and click Review Code Analysis, all that it's saying is that our class that we made, the sample OpMode, is never used. So this is not really a problem to worry about. We're still going to go ahead and commit and push, but that's a useful habit to get into to make sure that anything that you're making is not already flawed and has tons of bugs. We're just going to go ahead and still click commit anyway and push. It's going to go ahead and show you all of the commits that you've made and them being pushed to your testing branch. Now that we're done with that, so now that you've pushed your updates, you can go ahead and go back to your file, reload it, and then you should see that you had a recent push. If you go ahead and click down to your testing, you should see that we don't have any updates here. But if we go to our testing branch, then you should see that we have our MeepMeep testing module. And if we go through team code, main, team code again, you should see that we have our tutorial file and our sample OpMode. So everything has been properly pushed over and we're all set here. Now, in order to merge these branches together, we're going to go ahead and make a pull request, new pull request, and then we're going to take the testing branch and put it and merge it into the base. There shouldn't be any problems. Everything is green. We're going to create this pull request, remove that description, and create it. And now it's going to go ahead and check if there's any conflicts with the base branch. If, for example, and this is where GitHub comes really in handy and why we make different branches, if two different branches have changes made to the same file, then you have to go in and figure out which file is the one that you want, or go ahead and go line by line and add or replace or remove different lines in the file. But of course, since we didn't make any changes in the main branch and all we had was changes in the testing branch, we have no conflicts. So we're going to go ahead and merge it, confirm that merge, and now that we have successfully closed our pull request and we have no need for this testing branch anymore, we can go ahead and prune or delete it. And now if we go back to code, we should see that not only do we have one branch, but all of our changes are now on the master. So it is incredibly, incredibly important practice to start working with branches. If you haven't worked with GitHub before, I'm going to just preach this out there. Do not have all of the coders or all of the programmers mess in the master branch and make all sorts of commits. Because maybe you are working in the master on one file and somebody else is working on the master with another file. Well, if they make a commit and you're working on a file, then you guys are already not synced up. Or if both of you are working on the same file and you both make commits, everything gets out of whack. It is better if everybody isolates themselves to their own branch, properly named, and works on any issues that they can solve there before making pull requests that everyone goes together, collaborates on, and accepts so that they can merge into the master. Always try and work outside of the master and keep the master as this safe, sacred haven that you use to store all of your perfect files. Anyway, I'm done with my rant now.
Alright, so there's one more thing we need to figure out how to do, and that's actually uploading our GitHub repository or our Android Studio code onto this robot. So what you'd need for this is either A, the Rev hardware client installed, or B, a USB-C connection. The first thing you want to do is locate your control hub's USB-C input. This port should be on the upper side of your control hub. Now that you have your USB-C connected to the control hub, what we're going to do is plug our cable into the computer. As you can see, I've connected the cable to my computer. What we're going to go ahead and do now is go to your Android Studio. You should click on the team code configuration. Instead of the MeepMeep, click on the team code. You should see in the top that you have a running device, the Rev Robotics Control Hub version 1.0. If you do not see this, it's probably because your robot is not turned on, so go ahead and do that. From here, all we're going to go ahead and do is run team code. Again, make sure your project is completely updated by going to Git and Update Project before you go ahead and click this run. I'm going to go ahead and click it now. You should see in the bottom that it says the Gradle build's running, it's launching the device. If you want to watch it build, you should see in the bottom left there's this build icon. Go ahead and click on that. Once it says launching on devices, it should show that the build is successful. All you have to do is wait for it to build. As you can see, the robot is blinking blue. This is a sign that what you're doing is working and all it is doing is uploading the code. Okay, you should see in the bottom right that it says install successfully finished. Mine finished in 23 seconds. Do not worry if it takes any longer or any faster. And you should see that your robot should eventually turn green, and that means that it's all worked well. If you go into your driver hub, you should see all of the programs that you have made, as long as you've dictated them correctly, show up and you can run them. In the top, it should show that there is some process running. You don't have to worry about this. You can just go ahead and click Stop Team Code. From here, you can go ahead and disconnect from the robot, and it's all good to go. You can also upload the code through a wireless connection. All that you need to do is download the Rev hardware client. Go ahead and search Rev hardware client. Go ahead and search Rev hardware client download. You see one of the first links is the Rev Robotics documentation installation. Go ahead and click on that. From here, go ahead and click on the download button. From here, you should open your Rev hardware client and see this. You don't see any hardware because we haven't wirelessly connected to it. From here, go ahead and find your Wi-Fi. Once you have properly connected to your controller hub's Wi-Fi, you should go ahead and click on the Scan for Devices in the bottom left. If your hardware is not being detected like it isn't for me, go ahead and close the hardware client and reopen it. If your hardware still doesn't show up, then I would suggest turning off your robot, waiting a few seconds, and then turning it back on. That usually does the trick, but you still have to connect to the Wi-Fi again. From here, all we have to do is go back to Android Studio. You should see in the top that you have the Rev Robotics Control Hub version 1.0. Now all you have to do is go ahead and switch to the team code configuration and press Run Team Code.
So yeah, we have now downloaded RoadRunner for all of our autonomous pathings. We've downloaded MeepMeep to visualize those autonomous paths. We've downloaded the FTC SDK for all of the software and objects that we could possibly need. And we have also set up our GitHub account so that we can work with multiple people on a single project with safe version control that can be properly managed. So yeah, that's about it. Thanks for watching. Enjoy.